this is our daily production board. So this is where we visually communicate the goals each day, and then any critical information from multiple different departments. So we start out in the production side. We have each one of our departments. We have patterns, rollover, green can, heat trail, all our different molding lines, and then closing, melting, core making, shipping, and then the night shift. So on the top we have our goal. So this is the goal for a number of molds or specific parts that have to get done today. So there'll be a number of molds, and then we have a middle line which shows the status. So that shows the status. A midday is when we kind of get done molding and prepare to start pouring. And that's where we update at midday the status of how many molds have been completed from each department, and then how much pour weight and cast weight that's going to amount to, so that our melt team knows how much to prepare the pour for that day. And then at the bottom we have any additions or quality remakes or issues that we have to communicate. So if there's a part that gets scrapped in grinding, for example, because of a vent broke off into the casting or something like that, then they can add that right away onto this board, and that way the molding team will recognize that immediately and can remake another mold before we disassemble the tooling and get the tooling hauled back out to the warehouse. So it's just a way to kind of expedite the communication for those types of situations. And then on the side we've got just business information that we want to communicate. So we have our sales order target, and then we have attendance, if there's anybody missing and who's covering for them. And then we have a quality section, so if there's a part that we have a quality issue with, that gets noted on here and then gets communicated to employees. And then we have our maintenance section that shows what our maintenance team is working on that day, so everybody's aware if there's a maintenance project in their area, that there's going to be maintenance team working there. And then any safety information or safety issues or anything that we need to communicate. All that's kept up on this board. And then we also communicate customer feedback, customer information with all the whole team. This is Mark Wicca. He's the lead of our pattern shop and also pattern repair work. And so right here we're in the pattern shop, and so Mark and his team do pattern repairs, and then we also store a majority of our patterns in here. So Mark will give you a little explanation of the shop here.
Hello. So we've got patterns that are in their own boxes that run on the rollover machine. If you look over here, they're stacked up. I have everything located on the computer. This being the east wall, I just made it simple. I've got row E1, E2, E3, everything's on the computer. There's different size boxes. We have a 48-inch mounting plate for the machine and a 66-inch mounting plate for the machine. Over here we have our squeezer work on these shelves over here. And again, it's just row 1, 2, 3, 4, and each section's A, B, C, and each shelf 1, 2, 3, 4. That's how I got them on the computer. A lot of the work on the rollover machine, we have rollover boxes where the pattern's in its own box, but we also have what we call insert boards. And that, depending on what kind of pattern you have, can save money for the customer because you don't have to build the whole box. It'd just be on the insert board. Which is like these. We have a pin and slot set up. We have nesting boxes over in our production area. A pin and slot is how they go into the nesting box, how they get located so you don't get your coke and drag mixed up. We have inserts that are 22 square, 26 square, 30 square, and 36 square. That's what we call a rollover insert. And then we also have several loose piece patterns too that we just lay out on the table and make those loose. And there's what we call floor molding or east rail. We're putting flats onto cope and drag boards. which is some of this larger work over here. Open drag plate, and the flash sits on top of it and fill it with sand that way. Kind of diversified on what you can do for patterns. The building here is 60 by 200 feet, and we also have two other little warehouses located not too far from this building, where I keep a lot of rings and stuff for culvert molding. There's probably roughly around 5,000 patterns, give or take, in this building here. And we take care of the pattern repairs. We always look at the patterns when they come back from production. If there's any dings or anything that got in there that I notice, I'll patch them up right away so they're ready to go for the next time.
Here we're in our green sand molding area, so we have two squeezers for doing green sand match plates, so we can do like low volume, primarily low volume, one-off stuff. We can use either a match plate squeezer or loose patterns, where we can make the molds here. So green sand molding, castings up to about 75 pounds max on this line. Okay, so this is our rollover line. This is where we do all of our larger air set or no bake molds, and we can do molds up to 6,000 pounds in gray iron on our air set line. And so this rollover system is designed, we primarily run in our own boxes, or we have insert boards where a pattern or an insert will be put into one of our production boxes. And so the boards get mounted, they run in this system. It's an automated rollover system where the pattern goes in and it rolls over, and the pattern and mold are separated. And here you can see an example of one of our production boxes. This is a typical rollover production box. So all the patterns with the getting runners and everything are mounted. And this is its own box. So this mounts on a pallet system that runs through our rollover line. This is our rollover line where we're doing the air set or no bake molds. So we do all our larger molds, larger castings on our air set fan. So here we have production boxes where all our patterns are mounted in. They run through the rollover system that separates the production pattern from the mold. And the molds go down the coke and drag line to have cores set and be assembled, and then the pattern circulates back to it.
have two sides here. One's our drag side, and this is where we prep. And as you can see down here, I have a couple molds prepped here. On the other side is the coach side, and that's where right now he's prepping it, putting all the vents in it. Once he gets all the vents in, he grinds out the downspout so there's good flow. He blows it out completely. Our molds are blown out several times before they're closed to ensure no sand in the mold.
So this area is our shell core production. So this is where we make the cores that go into the molds that are baked cores. So they're shell core for their stability and strength. And so we blow sand into a heated core box, bake it, and then separate it and pull out the hot core. So we've got two different dependable sand core machines, and then we've got one smaller dependable over there. We can run all sorts of different boxes up to about 18 inches in size. This is our snow-baked core production area. So this is where we have boxes that are large cores or boxes that we have to fill by hand with snow-bake. So we've got a mixer and a process here to fill those cores and make them manually. So we're in our melting department, and this is Justin Barst. He's the lead of our whole melt area and all the melt departments. He's also on the American Foundry Society Pupil Vision Committee, and so he supports a lot of the AFS efforts and pioneering new strategies and communicating with things going on related to pupil operations. So Justin's going to explain kind of his process and all the systems we use here in the melt department.
Hello everybody at John Deere. First of all, I want to say I hope everybody's safe and healthy. I'll run you through our process we have here. My general process starts with the pupil over here. I melt out about 3,000 pounds per tap. And then that gets put into our holding ladle. It goes out there. And I take a test. Chip the test off of every single ladle before and after, so we can check out the chemistry changes and the quality of the iron. And this is where I get my result. The reading I have right now, that's the perfect iron. That's right where we want to be, 350, 220. And after we test our iron coming out of our cupola, we send it off to APL, Analytical Process Laboratories, and they send us back their results of the quality of the iron, and it's pretty much spot on. So, I mean, everything that we do with the quality of our iron involves a lot of data, and we just make sure that it's being poured when it needs to, at the right time, because after a certain time the quality of the iron deteriorates. So we're always making sure we're on time, on point, and the quality is where you need it to be. Okay, this department back here is our charging department. This is where we make sure the right amount of weight, steel, cast iron, coke, rock, manganese, silica is all being added properly to be charged into our cupola here. We had 700 pounds of cast iron, 300 pounds of steel, 24 pounds of silica, 35 pounds of rock, along with 1 pound of manganese. And that's
so we get the correct chemistry coming out. This is our cleaning department, so all the castings get took out from our pouring floor, and then they move up into our cleaning department. We first run them through a steel shot blaster, either a cabinet or a wheel abrasive style. So that's our large cabinet blaster where we just hang the castings, put them in, steel shot blast them, and then they go into the cleaning area. All of our sand we reclaim, so the took out sand gets put into a sand pile to cool down, and then it goes into this mechanical reclaimer where we vibrate, break it down, and then the mechanically reclaimed sand gets blown back to the molding area where we have a thermal reclaimer where we burn the chemical out, and then we completely reclaim and reuse that sand. Our main pouring floor, so this is where all of the air setter no-bake molds are assembled, cores are put in, and then we do all the pouring. So we'll pour about 30,000 to 35,000 pounds a day out here on average. And so we've got a 3,500 pound ladle that we pour typically with. Larger castings will do a double pour with two 3,500 pound ladles, and then they're transferring right now iron over to our green sand side. So the iron gets transferred over for the smaller molds to our green sand line with a 350 pound pouring ladle on that line. So this is our green sand pouring deck. So this is where all the green sand molds have been assembled with the cores, molds are put together, and they come out on the pouring deck, and we pour all the green sand molds here with a smaller 350 pound ladle. So a lot of the castings that we're pouring here are 50 pounds or less, and so they're all poured specifically on this line. This is Brian, and he's going to explain how he conducts all of our different sand tests for our green sand and air set sand process.
Right here I got 3 samples. We have 3 dog bones. I put them in this machine, it breaks them at a certain point. Then I average it out and I get my tensile strength, excuse me. Then we chart it, we do a test every other day. We chart, so we have a running chart, and then as far as we do sand sieve analysis to make sure our sand flows equally through all the sieves. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we have our bottom pan. This way I can tell if the sand it starts out low, and you make a curve. Yours in the 50 and 70 pans are the ones where you want to see your curve go up. And then I document all that. Then I'll take a 50 gram sample and I run a magnet through it 3 times to get our metallics level. And then We do have LOIs. I measure up 50 grams for number 1 facing sand, number 2 facing sand, and then I'll take these bones and I scrape to get the 50 grams, and then I'll get my, put them in this oven right here, 982 degrees. You bake it for 2 hours, and then I'll shut it off. I'll let my crucibles cool off, and then once they're cooled off, I pour them back in, take the weight, and then I do my formula to get our lost LOIs, lost on admission.
We're in one of our warehouses where we store, this area is where we store some of our patterns for preservation of antique tractors, steam engines. One of my passions is preserving history, and the history of the agricultural equipment is primarily tractors and steam engines. And so this area, we store some of that stuff. We also have our quality chip area. So this is where we keep our test bars and our chips for metal certs, and keep all those records. We keep the records for about 6 months of every ladle that we've poured is stored there. And then we also have an area where our chemical and cupellum material and just some of our raw materials are stored here, also in this warehouse. And so this is just an additional storage warehouse for raw materials. There's some cores that are stored here, and then some of our quality data.